Okay, so I'm presenting and then we'll get going there. Please confirm once my screen is visible.
Yes, Prakash, your screen is visible.
Okay, thank you. So again, this is we are going to talk about today that partitioning and different methods of that data partitioning course, vertical and horizontal. Horizontal partitioning is also called sharding. So we'll talk about that, pros and cons. Caching, and then after that we'll dive into the caching part. I know I can imagine that basics of caching, some of you or most of you may be knowing, but I'll try to have some aspect of basically invalidation and what are the best practices we should use on that. And then of course, we'll open up for any questions and we'll wrap. Okay, thank you. So with that, let's understand that what is the basically why we need to do data partitioning, right? Why it is required, and why can't we just live with initial way of having just one database and just be happy with that? So the main reason is that due to the this big data wave or AI data and all those like huge data coming across from different systems, it's really hard to have everything at one place. It becomes challenging to manage. It becomes challenging in terms of getting a good speed, a good, I would say, read throughput or read response, right? Or write throughput. So all those challenges kind of are the real challenges when the data grows, right? So it's very difficult to have just in one system and be happy with that. So how we respond to that situation? So one, of course, popular way is that partition the data, right? And of course, there are different approaches that we'll talk about it that helps us to partition it well. Because one risk is that if we don't partition well, it may go even worsen to even the previous way. Let's say there is a big monolith database, and if you don't partition well, it can instead of giving us benefit, it can even further slow down. So right partitioning is equally important as the partitioning as a concept. Okay. So now I hope it's clear that why at all we need to partition, as the growing data to respond to the situation of growing data, to manage it better, maintain the performance. And of course, one other important thing is availability, right? The world we are living in, that the kind number of systems we have in and around, availability is very important. So this also gives us availability. Of course, with the cloud and all, availability comes with a as a given feature. But I think behind the scene, this is one of the other reason that why partitioning is kind of getting popular at this point in time. Okay, so further diving into that, yeah. So it can be potentially can be categorized into two different type of partitioning. So of course, vertical and horizontal, and that's where we'll spend more time on horizontal. But sometimes even vertical is also kind of useful if the data is not that big. I would say, in that case, it is useful. So basically, as you can see that, let's say there is a table with 4 different columns. So when we say vertical partitioning, essentially we are saying that divide the table into two different, divide the table column wise, right? So, vertical will say, so table partition one can have a couple of columns, just 4 columns in here, but in reality, you may have hundreds and even thousands as well. So basically, vertical partition, we are saying that divide based on their columns and of course attributes also we can say. So that's vertical partition. Uh, in horizontal partitioning, basically when we are saying, what we are saying is that keep the schema, you know, don't change the schema, keep the same schema. If there are 1,000 columns in a table, have all thousands, but divide based on their rows or records. So in this case, let's say 4 records. So Both partition will have the same schema, unlike the previous horizontal one, but the number of records will be different, right? So if there are four records, one, two can go into horizontal partition one, three or four can go into horizontal partition two. So that's a super fundamental of vertical and horizontal partitioning. Of course, when we talk about sharding, it comes from the concept of horizontal partitioning. So we'll spend more time there, but I was just setting a background so that we know that from where we are coming from. And of course, now we'll talk more on sharding. Okay, with that, let's talk more on sharding now. That's one of the main topic for today. Okay, so as we understood that, in the previous slides, that basically horizontal partitioning, that is a mother concept of this sharding, is basically keeping the same schema and basically break a bigger table into different shards. We call basically these shards. But there, you can imagine in real world, there are kind of different database servers, different machines, that can scale horizontally, right? The way to imagine it. So now, since we understood about sharding, so we also call these server as shards, right? So shard one, shard two, and of course there is a called sharding key. You can imagine is equal to a partition key. It will have the same schema. Of course, the data will be divided into different shards or different database instances or servers based on some certain rules, and we'll talk about some of those rules as well, or some approaches that kind of leads to partition basically data, right? And one other key point here is that if you read through the last few sentences, that data held in each shard is unique, right? So don't confuse it with replication or something, because in that case, data can be replicated or copied as well. Here we are saying that each shard has a unique data, of course, based on certain conditions, certain approaches that we'll discuss later. But they are having different data, right? And they are like independent of each other. That's very important. There is no relation as such in terms of, okay, if you coming from a typical, if you talk about basics of database, like we have references, RDBMS references also. That's the other side of it, that in this system design world, nothing is like absolute perfect, right? It's always come with the trade-offs. There are cases when this will be useful or this can be used, and there are cases when it may not be the efficient approach, because it will give something, it will have some pros and cons, right? So we'll discuss on some of those as well, that when we should be approaching this and when we can maybe find something else to handle that. So just coming on the previous sentence, that there won't be I would say reference keys on this one. So shard one, shard two, they're not like you can say like tables as such, because they are sitting in different servers, right? They're not on the same database servers. That okay, I have three different. I had a bigger table. I just broke into let's say employee table. So I have employee one and two. No, no, not like that, because otherwise they all will be in the same database servers, and that's not the concept of sharding. The concept of sharding is basically that moving the partitioning the data horizontally and placing them into different database instances, right? And different individual machines, not on the same machines. And hence, because there are different database instances, we can basically sorry, there was some trouble. Am I still audible?
Now you are audible. Your voice got breaked earlier.
Okay, or is it okay?
So if you can repeat last 1 minute of what you said, I think that would be great.
Is it better? Hello, I'm audible
Uh,
back.
yeah, you are audible.
Okay, so I changed my internet connection. Hopefully, this will be more stable. Sorry for the glitch. Uh, yeah, so let's continue. Okay, so yeah, so coming back, right, I was saying that these shards have the may not have the referential integrity, and that's other thing that we lose, but there are a lot of things that we gain in a larger distributed system. So that's where it is still a preferred choice. Okay, moving to the criteria I was talking a while back, that based on what exactly we kind of move the data into different shards, right? So these are the typical criteria. There are more, but these are most commonly used criteria which are used. Of course, the first one is arrange based. Uh, the way to imagine is that, let's say I can take example of Indian names. So although most names start with S or T or something, but yeah, we can have some kind of a range that may be A to, let's say, E certain shards, and F2 again next, like that goes on and on, right? So let's say there are different five shards, so we can have maybe five each, and maybe last one can have six, or first one can have six, right? So that way, there is another way of putting the data into different shards, right? Based on certain ranges that we can imagine that makes sense. So uh, that is one, I would say, criteria. Of course, it may have the problem of rebalancing. We'll talk, a little bit more later. But and hence this approach, range-based approach of sharding, is recommended for not so frequently changing data. If it is frequently changing, then the data rebalancing problem can happen, and it creates a different kind of problem that all the requests are kind of going into. For example, uh, let's say, just to illustrate that how data rebalancing problem may look like, let's say that uh, we are having a stream of data that is coming into different shards. Let's say we are in a geography where most names, on the same example of names, let's say most names start with maybe certain range of the data. And if we have the shards, let's say we say A to E and like F to and next, right? So like that, if we have, it may happen that certain shards have more data, because if we are taking the name as an input, maybe more people are having those ranges, and others are like, for example, in the last five, see, like X, Y, G, all those letters, very few names you will find in India, right? We start with X, Y, J, G. So the shards that have the last five or six letters will have very less data. So this problem is called data rebalancing in the in system design world. So this can happen in a range base, and hence the recommendation is that you should use this approach when the data is not too dynamic in nature. Okay. Next is key or hash based approach. So we can have some kind of a hash function, or like, let's say, modulo or something, or any other hash function we can imagine. And based on that, we can have that, okay, if this is input, this go, let's pass through with a hash function based on what comes out, put into the certain shards, right? The only challenge here is that if you use hash function, of course, it will have a fixed kind of function. So it will go into certain things. If basically dynamically, let's say, adding a new shards if you want to add future, that may be challenging. That may happen, but it may need not to basically having without downtime. So we might need to have some downtime to handle that, and hence that is I would say other downside of it. So, but yeah, it's better than I would say in terms of it can fairly do the good job of we can have a hash function and we can pass that new data into that function, and wherever it falls we can have, so that way we can maintain fairly consistent I would say load on different shards. That's the advantage of that. But yeah, we need to mindful of that, that for to add a new shards on that chain we might need to have a downtime. But of course there are ways to handle that. In case you folks heard about consistent hashing, there is a technique that kind of does the job without having the downtime. But of course that is a topic for some other time. But this advanced techniques, it also has its operational challenges. But yeah, just want to bring in that this approach, how this works, right? The last one is could be about directory based. So in that, uh, the way to understand is that, for example, I can have a mapping. So shard key, I can have a map table basically, or lookup table you can say. So like shard key and their shards maybe server name, right? So which keys is sitting into which server. So we can have a mapping table so that we can know if we want to fetch some things instead of going around, we can know that okay, this is data is sitting on this shard. So that kind of speeds up the read response. But what other trade-off could be that basically it's a single point of failure. So if the mapping server is kind of crash, so we might need to handle that. What kind of backup strategy we want to make on this lookup server or lookup table, so that we don't lose out the mapping, because mapping is key, because mapping is the first point that we'll encounter when we want to fetch the, let's say while reading, we want to get a certain key, we should know that okay, which server it is sitting there. So these are some of the criteria that are important on this horizontal partitioning or sharding. Okay. Again, I spoke about that in system design world, nothing is called absolute perfect technique that works all the time, all the places. There is nothing like that, unfortunately. So what we should be aware is that we, on a case-to-case basis, we need to evaluate, the, I would say, the business problem, the user load, what the functional requirement or the non-functional requirements, right? What's the growth looking like for next 3 to 5 years? All those parameters plays a lot. I would say role to decide that which is the suitable or most suitable strategy, right? Or in the circumstances, which can be the most efficient strategy, right? So sharding is good, efficient in a cases when we want to achieve scalability, because we are horizontally partitioning. One thing I would like to bring in here is that in a cloud world, right? That uh, you folks might have heard term like vertical scaling and horizontal scaling, right? So uh, we always say that vertical scaling is good for a scenario when we are not expecting a lot of load in the future, so we can increase the RAM or several components, right? That their volume, or we can increase their capacity. But only thing is that when we do that, might need to have some downtime, because it's hard to replace CPU with a more powerful CPU without downtime. At the same time, in horizontal scaling world, it's easy because we're just creating one more instances, right? So there is no downtime as such. Hence, the horizontal scaling is preferred over, over vertical in most complex systems, because it's very costly to afford the downtime. Hence, this is I would say recommended. And in terms of sharding, again the horizontal concept is similar, only thing is partitioning over here. So scalability is achieved because adding the new shards is not that painful than basically trying to experiment on the same. And again, that leads to higher availability because it won't be downtime as such. Again, the other advantage could be that since we are breaking the data, a large data into different smaller segments or smaller you can say table across different servers. And if we know that how to approach, how to read directly go into that due to the approaches that we said, for example, mapping one, right? That we know that this data is sitting on this chart. So we can directly go there instead of roaming around different charts. So we can save time. So if we have the right uh, strategy of sharding, the read response can be improved. And hence I think big systems like Facebook, Twitter, and all, they're using such things where uh, sharding a lot, and they have an efficient strategy that how to pull the data faster. And again, same goes with the write as well, because we don't need to, uh, I would say, deal with a bigger, I would say, shard. Rather, we know that okay, where is a which is the right point of shard to write, and if shards are like almost full or throttling, we can spin a new one and we can start writing on that one. So this is useful on these scenarios. Again, as you said, nothing comes with absolute perfect and everything is great. There is nothing like that. So the challenges that we might need to encounter is, or we need to find a workaround is data rebalancing. I gave the example of names that, let's say, certain if you have the alphabetic range, if certain names are more popular, then it may happen that shards holding on those names will be throttling. So how to rebalance this? Of course, I spoke about one technique called consistent hashing, but this is a bit advanced technique and it has its own operational challenges. So that's the one challenge we should be aware. And hence, I think the recommendation was that if you're using that approach, range-based approach, then we should have data should not be like too dynamic in nature, so that there is a fair amount of, I would say, we have, we are addressing that the rebalancing may not happen that much. Again, the other challenge would be the join operations, right? I think it's very, I would say, relevant to imagine that if you want to query across different tables sitting on different servers, because shard is a some concept come for different servers, um, you know, the join maybe can kind of cause a lot of latency as well. And hence the I would say schema design makes a lot of consideration here, that how efficiently we design the schema, how we keep you know schema of similar kind together so that this can be addressed. And again, I think I spoke about referential integrity as well, because these tables are in different servers, not on the same server. So of course, and they are independent in nature. And when we say independent, it means we are saying that there is no foreign key or kind of concept, right? And again, schema changes, right? There are schema changes. So we might need to kind of, this can cause some kind of a downtime as well, because there are many, automatically the schema may not change because they are like different shards are independent in nature. So it can't be like a cascading that, okay, you change into centralized servers and child servers will automatically grab it. Sorry, that's not the case here. So all this, there's nothing like a parent and child here. So all the shards needs to have this little, if there any change in the schema, they needs to get that. And hence there can be, some downtime. But again, the benefits of this, in most cases, kind of, I would say, override some of the challenges that we just spoke, right? But again, it depends on case-to-case basis. These concepts like sharding especially are used in large distribution systems, right? Large applications where data is distributed across geographies. So they're not designed for, I would say, not so complex systems, right? So for example, you can relate to the microservice as well. Microservice is not designed for Hello World or maybe HR or any not so frequently used, or not where the user load is like maybe hundreds and thousands. They're not designed for that. So like that, the sharding is also, it is designed for applications which are happy to have a lot of load and heavy load, not for I would say easy to use or simple applications. Okay, now I think I hope we're doing good on time. Yeah, we are. So We'll dive into this other concept of caching. I know this is not, I would say, as uncommon as sharding is, because sharding is typically kind of got popular with large distributed systems and with the flow of the data. But caching is kind of there since ages, right? We all have, I think, computer science background. We have, I would say, read in all those caching. So I'm not going to repeat the same thing. I think it's pretty common to know that. There are a few things that, of course, I'm going to talk which are relevant. Uh, One is, of course, I think I have not mentioned, but I can bring in here that in caching, there's nowadays like there are L1 and 2, L3 kind of caching also in there. The L1 is the most faster. When we say most faster, it also most costly. So that's the trade-off or design consideration we need to make. That what kind of cache we're looking for, right? Uh, and again, cache invalidation technique is also important. That will kind of discuss this, right? Okay. Other thing is that I think pretty evident whatever is written over there, primarily to basically it is used primarily to enhance the reading, provided that data is basically not different. So if data is getting changed frequently, as I said in case of sharding, there are use cases when it makes sense, that use case when it doesn't make sense. So same thing it's caching as well, that I have seen some people blindly start caching without even analyzing their design. So if the data is frequently changing, even you cache it, you're not getting a lot of advantages there. Very minimal advantage, and you end up paying a lot of money because caching is a costly hardware. Even you use Redis and all in cloud as well, it comes with a lot of cost, right? So what I'm saying is that in the current world, knowing certain things is okay, but knowing when to use them, when not to use them is even more important. So any tech you study, any design you study, always also pay attention that when these are not recommended, because what happens, especially people who just want to live with these buzzwords or just grab that okay, this is good and that is good. They don't really pay enough attention on the details, right? Because that takes time, that's sometimes even boring. But even it may be boring, but it's important, because if we don't do, we might regret later, because we might end up with design that is not relevant or that has not considered all the, I would say, uh, conditions and all the constraint that otherwise that should have been taken care of. So what I'm telling is that even for caching, we need to really pay attention that what's the value that are we getting? Is it really my case where caching makes sense, or not? That's something that we should be aware of. Okay, moving on. So again, I think how this works, of course, we can have the user, app server, cache. Generally it is before storage, so that if it is already in cache, you don't need to go back to the storage, because generally storage is like costly operation, because like IO operation happens there in any kind of I would say persistent storage, if you call, whether it's SSD, hard disk, or what's not. Typically, that's a model that app servers try to hit cache server in the cases when we are using or a lot of data operations, right? That's where it is kind of I would say relevant. Again, cache hit and cache miss are the common words that we should be aware of. Cache hit ratio is as again a parameter metric that is used, that how efficiently our caching strategy is working. Uh, you know, so how many times we ended up getting data from cache versus we have to go from storage. We have to get from storage. So our goal should be that uh, the cache hit ratio should be more, so that it means that we are leveraging the cache properly. We have not just added because somebody told us, and we have not just added because we know it. Rather, we have added it because it makes sense, because and we have analyzed the case, and then we have it. So if there's a case, then it's good. So keep analyzing, even you have just added by, okay, let's try it out first. That's okay to begin with, but don't ignore this cash hit ratio, because if you ignore it, means that you are paying too much to any cloud vendor or any any vendor for that matter, and you're not getting much value for that. So getting much value or getting value is equally important. As you grow in a career, you got to handle this cost aspect as well, not just that, okay, you know, this design and this tech. Design and tech is okay, but if it is if the same thing can be achieved with a lesser cost, that's what is nowadays people are looking for. Not just the tech, but the tech that is doing the job at the same time cost effective as well. So start paying attention to, if you're early in the career, don't just look into, okay, I know this, I know that. Also look at whether there is a best one, or whether there are any other approaches that can do the job with less cost. So that angle is also important. Not just that, okay, I just putting anything there. So analyzing cash hit ratio is a good parameter that tells us that even we initially put something, but now it's a good time to analyze that whether it makes sense. So you know, you know, it tells that whether reads are happening, and reads are happening from cache. Okay, again, very important concepts about cache invalidation and eviction policies. So cache invalidation is something that we have a couple of slides to go through that, you know, to understand that which can be the better case for hot. But cache eviction is something that pretty fundamental, that based on what I should basically, you know, thrash the, basically we should clear the cache, right? So first in, first out, uh, you know, if you want to clean the cache, clear the cache, if some data came in first, let's say, you know, 10 a.m. in the morning, if your cache is full, throw that away, right? So based on that, which data came first. Same thing, you know, the LIFO, and I think is similar to the queue and all, right? The concept. So basically, uh, the one that came last, clean that up. Least recently used, there's a good parameter that if you have some data in cache that is not that is very rarely used. It means that there are not much takers to that. It's just sitting and grabbing the space in cache. So you know, you can clean that and save your cache. Cache is, as I said, cache is very costly hardware, so we need to be using it wisely. So if it is data is least recently used, you can very much go and evict that. Most recently used, again, there could be some cases that mostly in chatting application, let's say, you know, you were chatting with somebody and you expect that the next chat will happen after a week or a month, right? So why you want to keep this for long? So again, it depends on which scenario you are operating. So in this case, let's say you had a chat with somebody and you want to have out a certain time. So we want to clean that most recently as well. Least frequently, again, you know, you kind of want to have, you're chatting with somebody and maybe occasionally chatting, and there is no schedule as such. You can clean that as well. And of course, you know, there can be some random thing as well, that okay, you don't want to have any certain rules, but we got to have some certain rules for sure. Uh, so generally, it is otherwise system will find something to kind of clean that. So it is generally recommended that you have your own rules, so that you control the system, not system controls you, right? So it's important that you take a control of that. You should decide that when you want to clean and based on what you want to clean. So it's important. Now, the last point on this, I would say, session is that about caching is cache invalidation, right? So there are three basically common techniques out there to invalidate the cache, and let's understand why it is important. I think that is also important, that why cache invalidation is important. See, I'll give you an example to make it clear. So let's say, uh, you know, there's an employee table, right? And somebody got a promotion and their salary, let's say 1 lakh was there, and it got 1.2 lakhs. HR, there is HR reports that needs to be pulled in. let's say you made that change into the HR database, right? Now instead of 1 lakh, it is 1.2 lakhs. Now, if your application by default reads data from cache, imagine what it will print or what it will fetch. Of course, one only, because you have not cleared the cache, you're still keeping the old data. And cache is a not a human. It needs to be told that okay, you should be clean, right? Not automatically imagine that now 1.2 happened, right? Somebody needs to tell that, and that somebody telling is called basically invalidating. That how we make cache consistent with database, so that if database has 1.2 lakh, uh, cache will also have 1.2 lakh. So there are strategies to handle that, and that is called cache invalidation, right? Now, hope you understand that why it is important. Now, coming back, the first strategy that write through, as the name suggests, write through cache. So what you do is basically that you first writing data into cache, and then you write into database, so that basically all the time cache has the data. Cache has the latest data. So if there is a new data, you first write in cache and then you write in database, right? So of course, cache has always the data, uh, and you read fast for sure. And there is a consistency because both have the same data. At the same time, for the cons is that for writing, if you want to write something, you always need to go with the cache. You can't directly go with the storage. So that's the problem. Means you add additional latency. Otherwise, you can directly write into database. So now you need to go through with cache first, right? So that's like additional, I would say, trade-off that you get. That you get a fast retrieval at the same time. Your write latency can be a little bit slow because now you need to go with a cache route. Next is write around cache, as the name suggests. It's just opposite to what you just first one, right? Write through cache. In this, you write in a database first. Okay. First, any write happens that it happens in database permanent storage. It doesn't happen in cache. So it will certainly increase the you know uh, write latency because you're directly going there. But the con is that reading may be slow, uh, and not just slow, more than slow, it may be inconsistent. So think about it. The case I just gave, right, that somebody's salary got increased from 1 to 1.2 lakh, but I have written into database, but I have not invalidated my cache. So my cache is still holding one. And application by default design in most cases, first it checks the cache, it finds one and it returns one. So, somebody got a hike or something, instead of being happy and they pull the report, they say, hey, my salary didn't increase, right? Uh, so it may create kind of inconsistent data and it may lead to some confusion, right? So that is a con of basically right around cache, that your cache is basically not updated immediately. So the chance of cache miss are more, uh, because the cache basically in this case cache is it needs to read information from database because it didn't find certain data. Uh, to give the example, let's say some new employee came in, right? So one was a inconsistent thing that I gave you about salary. One example could be about some new employee joined it, and that employee added in the database. And since there's a new employee, it's not cached. So what will happen? You click on the application, let's say HR application, and it will try to see that hey, it is in cache. It will not find because it has not yet written to the cache. It just written in the database. So the cache, if you recall the previous thing, cache hit ratio, right? That will be compromised because I didn't find the data in cache. It's a new employee, and so far it's not added into cache. So the cache, it will be cache hit, uh, uh, cache miss basically. Cache hit is the when we get that. So the cache miss scenario will be more because not everything is kind of mapped with the cache. Data is directly going into storage. So basically, the higher read redundancy, the writes will be faster for sure. So that's when these techniques are given to one to analyze them, that which is the most relevant, I would say, technique in my given case, and based on that, I should be deciding that okay, whether uh, write through cache is right strategy for me, or write around cache. If you want fast write, write around is better. If you want fast read, write through cache is better, right? So like that, one needs to take a call that which is the most relevant scenario, and hence the requirements comes in picture, that uh, is it a write heavy or read heavy? If it is read heavy, write through cache is a good choice, because it will make sure that cache has data, latest data all the time, and the cache hit ratio will be kind of great. If somebody kind of looking for write heavy, then of course write around cache is better, because one needs to directly can write can happens without going to the root of cache. So again, one needs to decide that which is the right strategy, in a given cache. Okay, now the last one is write back cache. So it's like I would say a smartest strategy. Out of these two, it have taken the best of both world, write through and write around. So write back is like, uh, you know, you when you have some data, you first write in cache for sure, but you don't write immediately into the storage. So you can have async calls to the storage. Okay, so the best part is that you will get latest data all the time in cache, because you're writing through cache. But only thing is that the the write happens as in a sync way, so you're not waiting for that, right? It can happen in a sync way. So basically, your writing is not that compromised. At the same time, your reading is also fast. So you know, so it's like a best of both world. Only thing is that you know that a lot of dependency on this. So let's say that there is some communication gap while writing to storage. Uh, there is some network outage or something. So it may happen that cache has the data, but it has not persisted well, because something happened. Something happened in terms of network, or hardware got failure. So the responsibility of cache is increased here in this case. So cache needs to write into the I would say storage. So cache servers like needs to be well planned, so that it's not single point of failure. And if something happens, it needs to be invalidated, right? So that at the same time storage and cache have the same data. It's not happen that okay, I have some data in cache, but it's not there in the storage. So basically, one needs to take a call that, but this is in most cases, this is I would say this comes out as a good strategy, good cache invalidation strategy. In most cases, it works well. Okay, so that's what I had today. This is something about me. I'm a senior engineering manager by profession. I'm ex Microsoft MVP. I was MVP for 7 times, and of course, C# Corner MVP. I do blogging. I'm also kind of speaks on different tech events out of passion. So all those things I do are passion. So uh, coming to the non-technical interests, I love music. I like meditation as well. I have a YouTube channel where I keep posting some video about cloud, about data structure, algorithm. These are my, I would say, topics that I enjoy. I like problem solving, I like system design. So out of passion, I do these things. So again, I have a blog, techieprakash.com, in case you want to visit. So these were the information about me. Okay, I'm open for any questions uh, on any other thing that I discussed.
Yeah, so everyone feel free to ask your questions. Prakash would love to answer your all your queries.
Hope it was useful. As you said, it is a starter. You know, some of these things are a good beginner starting point, and you know, one needs to really kind of go deep down, implement those, some of those, experiment those to get a expertise, right? So uh, I would say deep, keep keep your knowledge on keep increasing your knowledge on that. Uh, don't just try to read the, I would say, definition, go deeper that when it can be used, when it can't be used, so that you have developed a, I would say, sound is knowledge on that, not just the superficial one. Uh, yeah. So that's important. That would be, I would say, a piece of advice that I can give. In my career, again, we all learn from our mistakes. So this is something that I learned, that going deeper is important, because that way we can take right decisions. Okay, maybe a few more minutes I can wait in case somebody have questions, any feedback, any comment, feel free to post. Yeah.
Yeah, feel free to write down in the chat box your feedback or anything. How was the session? I hope you liked
Yep.
it.
Yeah. So I can see one question: does the cache exist in temporary memory in some cases? Does it generate every time? So it's a, yeah. So it's like a, you can say RAM actually. It is more costlier than RAM, more faster than RAM. So it's like a memory. That's why I was saying that it's a L1, L2, L3. That, this kind of cache memory. So it's like faster. It is as you said, it is a temporary storage only. It's not a persistent storage. That's when we need to kind of write into the persistent as well, in case we are using strategy that where they are like, cache is kind of first written, right? So we also need to write persistent. So yeah, it's a temporary for sure. Yeah. And it keeps, for the second part of your question, it keeps the, I would say, the data that is already there on cache. So we need to write explicitly that, to keep the data into cache, so that, and if we want to invalidate a certain point in time, we can do that as well. So we are the developers are the one who kind of keep, they choose that, okay, which data should be there on cache and which should not be there on cache. So it doesn't generate every time. It's just that keep the data as long as you want to. Uh, I think we were talking about different strategy that, okay, least, used first, or most used first. So you need to configure that how you want to control their life cycle there, right? So life cycle is equally important, so that we are using the cache memory well. We're not misusing it, right? Because it's a costly hardware. So we need to make sure that data that is really being you read so often is sitting on that one. If some data is not used frequently, why to kind of keep in cache? So we need to analyze, and we need to control it. Thanks for asking question.
So there's one more question in the Q&A section. For a
Mhm.
large existing database,
Okay, I'm just
I
trying to
hope,
read.
yeah.
Okay, I'm not able to read. Can you read on my behalf? I have some trouble, I guess.
Okay. It's actually in the Q&A section, but I'll read for you. For a
Mhm.
large existing database that wants to implement horizontal partitioning, are there any tips? Because there is a possibility of data loss and spikes during the implementation process, or switch to partitioning.
Certainly. So there are techniques actually. Partitioning techniques are there based on what we want to partition, right? So some people use that. Let's say domain-based partitioning. So I'm taking example of e-commerce site because it's very easy to relate. So let's say I have catalog data, I have user data, order data, payment data. So I have seen some people use that kind of strategy, like domain-based partitioning, that based on the domain, we can have partition so that the similar data is sitting closer, and we can I would say do the fast retrieval. So that is one popular technique that people use. Of course, there are other technique can be used based on the data itself, right? So we need to analyze the data, that how I would say what's the growth of data, what what kind of data it is. It is duplicate, it is unique, it is I would say it is in one country, it is a geo graphical spread, right? So based on many other parameters also, there are sometimes people use a country-based data, or they create partition based, one for India, one for different countries. So there are many techniques, and it totally depends on that which case are we dealing with, right? There is no one technique that works in all the cases, unfortunately. So we need to review the data, what kind of data we are dealing with. Uh, but I said that in most techniques, like I have seen that either the domain-based data or geography-based data are people are using it, yeah, to partition the data. Of course, other could be like a date base as well. Okay, I want to keep maybe year wise, right? That, or every quarter wise. So there are many strategies depending on which can give us the faster retrieval and also the not so bad write. And whether it's a read heavy or write heavy application, accordingly we take a call. So there are some of these consideration comes into picture before we take a final decision on partitioning. Okay, thanks for asking question. Any more
Okay.
question?
Thanks, Prakash, for answering that question. Yeah, so the question, I have put the question in the chat box as
Mhm.
well for the
Okay,
reference.
sure. Okay, I see. Yeah, so data loss, right? Elimination process or switch to partitioning. So basically, data loss happens generally when it is not persisted properly, I guess, right? When we have the horizontal partitioning, I think if you remember, I think we were talking that each shard or partition kind of keeps the unique data, right? Data loss happens when, of course, it may happen when I wouldn't call it loss. I would call it maybe while fetching it, it was not. Let's say there are some network glitch and all, right? That may happen. But generally, what happens that if it is critical data, if you want to be even doubly, I would say, confident that if some data is super critical and it needs to be, I would say, in a cloud world, generally they have some, I would say, replication already there. They have some like I would say nodes which are like there. If we have high availability, I would say, kind of plan if we have taken in cloud, then they keep some kind of a replica as well. So if some data loss happens, I think it's not too hard to kind of get it back, right? If it happens due to some server failure and all. But generally, I think data loss is handled if we have considered the configuration of high availability. If it is a critical data, of course, that needs to be defined. If it is not so critical, then I think people rely on maybe one or two servers, not more. Okay, how do you decide between write through and write back casting strategy based on the application needs? Okay, so write, I would say write through when we do write. So uh, let's me go back. I think this will be more clear. So when we say write through, basically what we are saying is that all the time, we'll have cache, and like we'll write in cache, and then we'll write into storage as well. So the problem is that it happens, I would say, synchronously. So it happen in sync on the same thread, right? So and hence the problem is that writes is slow generally. So coming in the write back, if you see this operation, right, from cache to storage happens, in a sync way. So your write, you don't need to wait for, I would say, your thread doesn't get kind of stuck. uh, it keep happening in parallel threads, so your write become faster. So that's the main advantage. Read is faster in both. Read it faster in both write through and write back, because you're first writing into cache. That's a good part. So you don't need to worry about your cache is having the old data, right? Still data. So that's problem is solved. But the catch is that if you use write back, you are using async way between cache server and database server. So your writes are basically faster than just one thread is doing the job. So in write through, your writes are slower, but in write back, even writes are faster, right? Reads are faster in both. So that's the trade-off, or that's the advantage that you get in write back. Hope it's clear. Thank you. Okay, maybe last one question we can take, Chaitanya. Else we can wrap, I guess. Okay, I hope we are clear now. Again, I just said I can share my coordinates again. In case some of you want to reach out. If you go to my blog, I am also I reply things on Twitter. Techie, I would say you can find my Twitter credential as well on my blog. So in case you have any further questions, you can very much I would say ask there as well. Let me, I would say, share my coordinates one more time in case somebody have questions, they can reach out. So let me quickly open that as well. Yeah, so these are my coordinates. If you are available in YouTube, you can connect with me in YouTube as well, and ask something. If you prefer more blogging, then uh, you can go to this blog. You can ask something over there as well, and you can find my Twitter handle over there. So that's the other way to reach out for any further clarification that you want to have, or you want to talk anything more on. So I typically respond in a couple of days in Twitter, so somebody reach out to. Okay, with that, I think we're good on time, Chaitanya. Thanks for this opportunity. I'll kind of, I would say, I kind of love talking to the people, and I hope it was useful. So, thanks for other people who joined. It's not easy, I would say, it's harder to kind of show up in weekend. So it shows that you're sincere enough for your learning. So that's a good attribute, I think, that you should continue doing that. Yeah. Of course, by keeping a balance of your personal life as well. So yeah, that's thanks for the good gesture. Thank you.
Yeah, thank you so much, Prakash, for taking your time in guiding us today about sharding and caching. I mean, these are the topics that are taught in a very boring way in colleges, but you taught us in a very interesting way. And I'm sure everyone had a great learning experience today. And in our next session, we will continue with sorry, my internet got break in between. But yeah, thanks for the insightful session. And we look forward to have more session with you in the future. And thank you once again.
Thank you. Thank you. Thanks everyone. Take care. Bye bye.
Thank you. Yeah, so everyone, do connect with Prakash on the social media handles that he shared. Do connect with him on LinkedIn as well. If you have any doubt, feel free to ask him on over LinkedIn. LinkedIn is a good way to get connected with mentors and experts. And I personally I will recommend you that. And apart from that, yeah, if you I'll share a feedback form with you in a couple of minutes, and once you fill out that feedback form, you will receive a certificate of participation for today's session. And if you share your certificate on LinkedIn, then do tag Prakash as well for the insightful session. And yeah, thank you so much, everyone. Thanks for joining. Just wait for a minute and I'll share the feedback form. Do mention your honest feedback, like how was the session, and is there anything that we should cover in the future. So let me just share the link in the chat box. Okay, so for the slides, I'll connect with Prakash and see if he can share the slides, and then if possible, I'll share you over the mail. I mean, to everyone who fill out the feedback form. So I have shared the certificate form. Let me just share it separately as well. So this is the feedback form. I hope you all can access it. Let me just pin it as well. So in the chat box, you can fill out the feedback form in order to receive the certificate of participation for today's session. Yeah. So thank you, everyone. Thanks for joining. I hope you all had a great learning experience today, and we look forward to have you in the upcoming session as well. So the recording of today's session will be uploaded on our YouTube channel, and if you want to revise the concepts and everything, you can you can subscribe to our YouTube channel, and you can revisit the recording.